So you might have seen that there's a common phrase that seems to be used at the launch of pretty much every new AI model, and it goes something like this.
Grok 4 is better than PhD level in every subject. It can reason at superhuman levels.
But with GPT-5, now it's like talking to an expert, a legitimate PhD level expert in anything, any area you need.
Now, as someone who's actually doing a PhD in maths, it does make me think that I might be becoming slightly redundant. However, no one really seems to be actually testing whether these claims are true. You know, everyone's using ChatGPT or Gemini, whichever model you prefer, but is what they're saying actually true? Are models like ChatGPT or Gemini actually PhD level in these kind of advanced level maths problems? We've done all kinds of testing on the channel, and today, continuing with these tests, we're going to see if these models, so ChatGPT Plus, which is $20 a month, Gemini Pro, which is also about $20 a month, and Super Grok, which we've still got. Of course, we've still got Super Grok, that $30, which was actually paid for by a comment last time, so thank you very much to you. I thought I'd lost it for good. Anyway, we're going to see if these three models can answer a question, basically a proof, which I proved in my master's thesis. Now this, when I proved it, I kind of believed was the pinnacle of what I'd written that year, so it must be, 3 years ago now that I'd written that master's thesis. And this specific result concerns what's called a conformal correlator, so it comes from a thing called conformal field theory, which is when you have kind of particles scattering from some number of points, and you're asking what that looks like if the whole actual physical system has what's called conformal symmetry, which is a kind of large class of symmetries. Details aren't that important, but I remember at the time this was pretty much the proudest moment, I would say, of my master's thesis, and I look back on the time proving that with like a lot of joy. So are the clankers going to be able to do the same thing? I'm a little bit worried. I think the results are going to be pretty surprising. So let's jump straight in. I want to say a huge thanks to everyone who's supporting the channel. The hypes have been absolutely incredible. Anyone who's supported the channel as a member is like, thank you so much. I can't thank you enough for that. We've now got some new clanker badges. So if you join, you get to have a clanker badge. And there's the great coveted universe clanker badge that comes after like being subscribed to an obscenely long time. So I don't expect anyone's going to get that, but I think it looks really funny. You guys are absolutely awesome, and thank you so much. And the question, so firstly here is basically my master's thesis, at least in overleaf, as you can see, kind of is fairly long, 45 pages. So 45 pages plus some kind of computations in what's called Wolfram Mathematica, you know, proving some things that were relevant at the time. Let's see what Super Grok got. I've actually given it the first section of the master's thesis where I explain all of these concepts, like where you impose these symmetries, blah, 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 and done all of this. And basically what I'm asking it to do is an outline of the question that I had, that I was trying to answer myself. So it wasn't kind of given to me at the time. Basically with the supervisor, she kind of suggested, there's this proof of like what's called a 3-point correlator function. So it's like a scattering amplitude evaluated at 3 points. We've actually kind of given it the proof for the 3-point correlator. Now this is a proof that's actually quite widely available, and I must have read it in some lecture notes, which I could give the reference for, or that it will be in the master's thesis, but in any case, you get something like this. But what I've basically asked all of the models to do is to take these results. So here is a proof basically outlining the 3-point correlator function that you get from imposing conformal symmetry. I'm asking it to prove the 4-point correlator function, and then to use this to try and figure out how you actually get the n-point correlator function. To go back to the thesis, I'm just going to say at the time when I proved this n-point correlator function, sure, it was known, but I have to say I never found a kind of source that put it in the same form that I've stated it in this result. I said, as far as like I'm aware, there's no kind of statement of this theorem. There's ways in which they do state it, you know, in conformal ADS CFT stuff, but they never kind of put it in this same form, which is kind of strange because actually if you want it to agree with the more simple cases like the 3- and 4-point correlator, it didn't make sense to me why you wouldn't want a generalized form for this structure specifically. And the form that I got was something like this. And this took a long time. I think it took about a month at the time, and I would say it's about half the kind of nice result that was in the master's thesis, and to me it was definitely the most memorable one. Okay, so we've asked the three main models the same question. As you can see here, we're in ChatGPT on extended thinking mode, we've got Grok also on extended thinking mode, and we've got Gemini also on extended thinking mode. Obviously we're going to start with Super Grok because it's the most expensive, so surely it's most likely to get it first. So the 4-point correlator, it does that, it does a lot of stuff. It defines this, which is natural at the time. Of course, this was a long time ago that I've actually done this, so you know, I'm not that familiar with it. Surprisingly, you kind of do forget these things. And here, this thing is the beginning. So this bit here shows that it's managed to actually get the structure for this 4-point correlator. And here we are. So a particular solution is found by plugging in P times the sum of I and J plus Q times the sum of all of them. Yeah, and I have to say that's pretty cool that it's managed to get this. Like I said, this is a problem that was in my master's thesis. It's not like a groundbreaking thing, but for me at the time, it felt like a big deal. And it was very rewarding to prove the general case myself. I don't know if this is depressing, to be fair. So this is, so as you can see here, if you factor out the n-2, the 2 over n-2, and you go into here, see 2 over n-2 delta I delta j added up minus the 1 over n with the sum of all of them. So it's, yeah, it's the same thing. So Grok managed to get the result that took me ages when I was a master's student. Bruh. And let's see how long it thought for. So it says response time like 280 seconds, which is what, like 4 minutes? It's about 4.5 minutes, I think. This is actually kind of mental, actually. I have to say the proof here is actually pretty nice, and I think this is actually how I did it, was by kind of trying to say which factors are brought up by imposing each symmetry. I just remember at the time when I worked it out, it just made complete sense. Obviously now I'm reading back, I don't really remember. So overall, you're going to impose like this prefactor, I guess, when you impose the symmetries. That's like how conformal correlators transform, ends up like this, and you get the n-point correlator. So how did ChatGPT do? I'm going to assume that it did manage to get the 4-point case, because I think that's pretty much a solved example. So it did. You've got the same factor here. But I think ChatGPT is stating more something like this one. So this 1.86, this equation here, if you add up the powers, it will add up to the same factor as this one, I believe. So, but the important thing is really to see the main result, because that's for the general case. So actually ChatGPT didn't get the form that I kind of wanted it to, because I'd asked it to give a form that was in the same structure to the example I'd given. It technically is true, but it's not actually following the prompt as I'd asked it. So actually Grok wins astonishingly in this case. So I say, okay, I want the CIJs to be written in terms of these other parameters, and if we scroll down, we see that we do indeed get the exact same result. So there's 2 over n-2, delta I, delta j, blah, blah, blah. And so we can conclude that ChatGPT did also manage to answer a question that took me ages during my master's thesis, which is kind of crazy, actually. Like, anyway, let's see if Gemini manages to get it, and then we can conclude as to which models did the best and which models did the worst. So as you can see, Gemini's given the same final form for the 4-point correlator as ChatGPT did. Actually, Grok, you know, I'm not gonna lie, I think Grok's one was better, in my opinion, just because it was slightly closer to what I'd actually asked it to do. And as for the n-point correlator, if we scroll through, we see we've got the right number of degrees of freedom. So Gemini actually failed here, so we're going to ask the same follow-on prompt as we did to ChatGPT. When I say it failed, it didn't technically fail. It did give a correct answer. I suppose the problem is that I asked it to represent a specific case of this, which reduces to the known cases in the 3 and the 4-point case. What? So for the general n-point case, it's strictly impossible to write the exponent Cij in terms of only the scaling dimensions I. Okay, so we're going to ask another follow-on question to Gemini. It's indeed possible to construct a specific symmetric analytical solution to the exponents that works for any n bigger than 3. There. So as you can see, when you add them up, they do add up to this. For n bigger than 4, this is just one slice through the space of possible solutions. The full solution is this expression multiplied by an arbitrary function of conformally invariant anharmonic ratios. Okay, well, that is what I'd written here. So this is the f, that's the function of the anharmonic ratios. So I guess I don't really know what to think of this, because Gemini kind of said that it was impossible. Yeah, so as you can see, so really it's this, which is what I was asking it to do. And it took more follow-on prompts than the other two models. I guess it did raise the fact that it's actually kind of an interesting point to make. But likewise, ChatGPT did also make this point here. So it's saying that these Cij can be any solution which solves this set of equations. But if you equally split between the kind of variables that you're using, which are called these cross ratios, then the general form that you get is indeed the one that I kind of proved. So it's quite hard actually to say which model is best. I would say personally, maybe Grok gave the best direct answer, because it actually did what I'd asked it to do. ChatGPT probably second, and then Gemini third. For Gemini, it took kind of two follow-on questions for it to actually do what it said. So at first it said it was impossible, but then it said that it was possible. So it didn't actually give a configuration that agreed with the other one. So it obviously was possible. I just don't really agree fully with what it said. I mean, I understand what it is saying, but I'd kind of in the prompt asked it to do a specific reduction of this thing. So in a way I feel like it's not actually doing what I'd asked it to do. But that said, it could do it because it did manage to do it after enough prompts and enough guidance. And surprisingly not that much. Now unfortunately it doesn't say how much this model thought for, but it was about 4 minutes on each model, which is crazy. It's a bit like, you know, you spend all of that time during your master's thesis trying to prove something, and then like ChatGPT comes along and is like, it took me 4 minutes to solve that problem. I mean, I can't remember exactly how long, but it was definitely over 2 weeks. And like I had to learn this stuff as well. So what do you think about this? I'm kind of blown away. I'm kind of left wondering what my master's thesis would look like if I did it nowadays. Obviously now I'm doing a PhD, so it's a bit different, but the degree to which it can solve problems, like it's doing a lot of computation, like algebra. This is stuff that I wrote down on paper. Like I remember when I proved this, it was like I'd gone to a classical concert and I was like so obsessed with trying to get this endpoint correlator function in a form that was like, that agreed with the ones that were kind of written up in these like lecture notes and all of these kind of documents that we were given to read. And I just knew that there must be a way to get like a form which reduces to the ones that everyone computes, which is like the 3 and the 4 point correlator. But I always wanted a form which flattened out to the known cases when you put n equals to 3 or n equals to 4. And the fact that these models all managed to get it is just a bit strange. And it took so much less time for them to actually get this answer than I did. Like it took me weeks of thinking about it. You have to understand things that everyone's already done that are obvious and that are written up in the notes to even have a chance at trying to get the slightly more general form. Now, of course, this wasn't the whole of my master's thesis, so to say that ChatGPT could write a master's thesis, I don't know. The fact that they solved it in 4 minutes is kind of mind-blowing to me. I guess this is a question that maybe is because it's for a master's thesis student, it was more doable. But I actually remember it being less doable actually than a lot of problems I've done on my PhD. It has kind of always stuck with me as being something that I enjoyed proving and saw a lot of beauty when it all kind of went together and all of the symmetries added up to make this like collapsed form that looked really, really nice. So yeah, to see that ChatGPT, Grok and Gemini got it, you know, even Grok got it. Grok got it the best actually. In fairness to Grok, you know, it did actually get it, like, I would argue better than ChatGPT and Gemini, in my opinion, although I think someone could debate this. Like, you could argue that Gemini's was the best, but at least for what I'd asked it to do, I think that Grok's answer was the best. I'm not a Grok shill, by the way. I was bummed out when I spent $30 on it, but I had to take the L for science. But yeah, it was actually pretty good, I have to say. And in my opinion, I think it actually solved this one in the simplest way.